Ready-made apps like Blynk are great for getting started, but if you want full control over the design and functionality, you need to build something of your own. Today I will show you how to use Flutter, one of the most popular mobile frameworks, to create your own app and connect it directly to an ESP32. No middleman, no cloud, just 100% control in your hands. For this project we are going to need an ESP32 board, in my case the XIAO ESP32-C6, an LED with a resistor like 220 ohms, and the Flutter environment installed on your machine. You can find a link to the installation guide in the video description. The principle is simple. Our Flutter app acts as a client that sends an HTTP POST request over the local Wi-Fi network. On the ESP32, we will run a mini web server that receives this request, extracts the data in JSON format, and changes the state of the GPIO pin connected to our LED accordingly. We will start with the ESP32. In the code, we provide our Wi-Fi credentials. In the setup section, we configure the LED pin and initialize both the Wi-Fi and our server. This part is crucial. After starting up, we print the device's IP address to the console. This is the exact address our app will send request to. The heart of the code is the LED endpoint, which we assign to the handle LED handler. This function reads the request body, toggles the LED, and sends back a confirmation. Now for the best part, the app. We open the terminal, type Flutter create LED, and jump into the project. If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Altium Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Altium Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections. I've prepared a minimalist and elegant control panel for our LED. The key elements are animated container. This ensures the transition between the off and on states in the app looks smooth and professional. Toggle button, a switch that doesn't just change colors on the screen, but triggers the toggle LED function. This function packs our state into a JSON object and uses the HTTP library to send it to our XIAO's IP address. Let's fire up the simulator. I click the button and voila! The LED on the board lights up in a fraction of a second and the app interface reacts perfectly to the change. Super simple. As you can see, Flutter and ESP32 are a powerful duo. You now have a foundation that you can expand with sensors, charts, or control for multiple devices.